here if I take a left turn or a right turn, I can give different attribute on the basis of the time. So these things are very much possible. So you can see that the creation of a data is the most important part of the networking analysis. Similarly, you can have ordered and unordered pathfinding. Ordered optimal pathfinding is the sequence in which places have to be visited matters. So unordered optimal pathfinding is the sequence does not matter. So you can even also tell, like suppose you want to travel different tourist places, you can order them, like I want to travel first tourist place, then I want to go to second tourist place, you can then third, and then fourth. So automatically it will make a tour plan for you from moving from 1 to 2, 2 to 3, 3 to 4 in an optimal manner. So it could be in ordered form, or it can even be in an unordered form. So both type of conditions can be applied to this particular networking analysis. Then you have you can also provide a networking allocation. While the purpose is to assign lines or nodes of a network in a mutually exclusive way to a number of target locations. So what basically do, you try to allocate a resource capacity, the capacity with which a center can produce the resources, the consumption of the resources, which may vary amongst lines or line segments, like some streets have more children. So those type of allocations can be applied to a particular point. Like you can see that here this is a shopping mall, and it will serve the purpose of these number of streets. So you can even have allocation like this also. So this type of allocations can be created for different type of centers, different type of shopping malls, even cinema hall and all. You can easily see, like this particular point will serve to this. Like for instance, hospitals automatically these number of people will get benefited, which are residing in these streets from this particular hospital. So this is also one of the very good utility being used in networking analysis. Then called the trace analysis. Trace analysis is basically performed in the hierarchical analysis, wherein you generally have a upstream and a downstream, wherein you try to calculate the flow accumulation and the flow direction. So trace analysis is performed when we want to understand which part of a network is conditionally connected to as a chosen node on the network, known as trace origin. So maybe you can say that this could be an outlet, so you can directly select what are the number of channels which are contributing to the outlet of this particular thing. So you can even draw a point over here. Automatically it will show you what all channels are contributing to the output or the outlet of this particular thing. So you can use this trace analysis in various hierarchical modeling, and this is very important. Like flow accumulation and flow direction is one of the example of the trace analysis. So the last part is the most important thing is the error propagation, which basically talks about how much error is propagating in different stages of our generation of the data. Like if you see that, if you talk about a real world, you try to generate your data sets. So the moment you generate a data, there could be n number of errors which will propagate into your spatial input data. So those errors will be there, like if you are using some legacy data sets, if you use these legacy data sets, then some of the errors will propagate in your data inputting. And then after that, you do certain analysis. Now if you do certain analysis, there could be some process error. Now when you do your processing, you will have some additional errors which will go into your system, and then you will use the same error for planning and human decision making. So what will happen, you had error at the input level, you had error at the database creation level, you had error at the level of analysis, you had error at the generation. So these gaps between the reality and a model of it should be reduced. So you have to be a little bit careful in calculating this. So there are certain ways. So errors propagate through different models. So error propagation analysis, testing the accuracy of each state by measurement against the real world, and then modeling error propagation either analytically or by means of simulation techniques. So there are various ways of analyzing these error propagation. So basically error propagation in spatial data, like you can do the modeling error propagation, which is anyway is a mathematical model which describes the mechanism whereby errors in source data layers are modified by particular data transformation operations. So what you can do, you can if you have certain benchmarks of your actual data sets, you can try to transform those data into the real data set so that you can reduce the error in your data. See, ultimately, if you have an error at different stages, it will multiply at the end. So it may lead to a lot of errors when you do any sort of modeling. So models of error propagation you can try. Then models describing only the propagation of attribute errors, like models incorporation, both spatial and attribute error propagation. So you can apply this error propagation to your existing model in order to remove the errors. So there are certain spatial data quality measures. Like suppose if you have input your data, you can get the line accuracy, you can get the area accuracy by calculating different RMSE error. So with the help of these errors, you can try to simulate your errors and try to reduce your ultimate output. So that is our basic objective, how we can achieve the error-free output. So this completes my entire lecture. Thank you very much.